Okay, keep in mind that all we are doing is scratching the surface. Okay, you were going to do tons with polar coordinates in Calc 3, but for us, we're just going to barely scratch this surface, all right, of Calc 3 and what we've got going for it. All right, so I just want to set up the basics, or not of Calc 3, of polar coordinates, for crying out loud. So I just want to set up the basics of what we've got going. Now, this is what I want to talk about. This is how we live, right? We live in this coordinate system, this XY coordinate system. This is where we dig all the time. And it works great if you have these squares. But look at if I have something that's a circle. This whole entire time, I'm looking up here at my quadrants, these quadrantal angles, but nothing else in between here is crossing, right? So all this whole quadrant, none of that is actually on my coordinate system, so it's very difficult to graph. NWalks, polar coordinates. So polar coordinates in the polar coordinate system is set up for circular graphs. That's the whole purpose of it, is these circular graphs, these polar coordinates. The polar coordinate is r theta, all right? So if I'm looking at a coordinate point here, it's not an xy, it is r and theta. So to get out here is going to be r, and then my theta is the angle measurement to get to that point. So my coordinate point right here is the coordinate point r theta. All right? So it's not an xy coordinate anymore. It is r and theta. We're on this circular graph that we have. All right. Now here's the other thing that goes with coordinate points. Back here, to get to this point, this is negative r theta. All right? Anytime you have this negative in front of the r, that means reflection. So it's not a negative radius, because we're talking about radius and theta, right? So you're not having a negative radius, it is a reflection in order to get to the other side. So here's the other thing that's associated with polar coordinates. It has infinitely many answers. So to get a polar coordinate, you can have infinitely many choices here in order to be able to pull that off. All right, you can have this positive r value to get there. You can have the reflection to get to the other side. All of that is the same. So knowing that this is the reflection, your reflection there is going to make that impact. All right? Okay. Check this out. Let's graph some. I'm going to go back to blue here. So here's example 1. There's 3 of them that we're going to pull off on this. We want to graph these points. The first one is point Q, and it is 1 5 pi over 4. So if we're looking at our coordinate grid, all right, so 1 is that radius, so I know I'm just going out 1. Where is 5 pi over 4 if that's my theta? Yeah, this is 4 pi's over 4 right here, this pi value. 5 pi's over 4 is down here. So if I'm going to get this coordinate point is 1 5 pi over 4. Do you see that? Okay, so also at that value, I can have, so if I want to graph points and it says come up with some alternates. What if I'm coming from this direction? What is the coordinate value there? Still 1, but what's that angle measurement? Yes, it is. Negative 3 pi over 4. You nailed it, right? If I'm going in the counterclockwise, I know that's a positive angle, but this same angle has this coterminal side. So I'm looking at something that's coterminal in order to pull that off. You can also look at this being written as another whole swing around, right? So if I'm looking at this, I can have a full, so this is 5 pi over 4, then I can swing it all the way back around again to get another coterminal angle. So you could just add 2 pi to this, add 2 pi, add 2 pi. So you see, there's lots of options that we can go for there in order to pull this off. All right, let's do this one. What if I have R? R is -1 7 pi over 4. Now, what does that negative represent again? Yeah, that's going to be a reflection. So, if I have this at -1 7 pi over 4, where is 7 pi over 4? Yeah, down here in this fourth quadrant. This whole thing is going to send me all the way around here to -1 7 pi over 4. So if I'm talking about my reflection, then what's this one? +1, but what's the angle measurement that goes with that? Where is this actually? 3 pi over 4. You see that? Okay, so when I'm talking about my reflection here, then it's -1, but then that 1 is at 3 pi over 4. Well, what's another angle measurement that I can go for there? Yeah, and so another thing is you could add that 2 pi to it, right? To get that coterminal. So I've got 1, and then if you have your 3 pi over 4 plus 2 pi, which are 8 pi's over 4, that's going to give you that 11 pi over 4. I just want you to see. So you can add 2 pi to it. You can make a negative angle measurement and pull it off. I could come around here and I could say, oops, I didn't want to do that. I wanted to do this. I could come up here and say, okay, I'm going in this direction. And then what's that going to look like? -5 pi over 4, right? So however you want to do that angle measurement, you can. Just I want to make sure you realize that that negative is a reflection in order to get there. Okay, let's do another one. Let's go red. We're getting all colorful. If I have a point S of 2 and -3 pi's over 2. Where's -3 pi over 2 going to hit? Going in the clockwise direction, and it's going to send it right up here to -3 pi's over 2. Because it's going to hit it right up there. So this is the point 2, -3 pi over 2. What is that point also? Yeah, pi over 2. What if I wanted the reflection down here? Yes, so we could have -2, and then the actual angle is 3 pi over 2. So whenever I'm talking, so maybe we need to make that point. Let me bring it back up here. When you have the R is just a reflection, but your theta is still the same theta so that you know where it goes. So this theta is actually relevant to this angle measurement to get all the way over there. All right. Your theta is not negative also. The negative theta just means you're going in the clockwise direction instead of the counterclockwise direction. This negative here just means reflection. All right. But the angle is still the angle no matter what, like a normal angle. All right. Okay. Okay, so putting that on there, you can, just like any kind of coterminal angle situation, you can come up with infinitely many that you have. All right, good.